Hello, this is Gigi from Quadratic Community College. In this video, we will be completing the square to write a quadratic into their vertex form. Alright, so, and we write it in the vertex form so that we can tell where the vertex is, and most likely we are graphing the function. Okay, so suppose you are given f of x in the form of ax squared plus bx plus c, and we need to write that in vertex form, and the vertex form is a times x minus h squared plus k, where hk is your vertex, and the a right here is your vertical stretch or compress, right? Vertical stretch or compress, and then it might be flip over if it is a negative number. All right, so here we see that there is a perfect square denoting the quadratic, so we need to remember what a perfect square looks like, right? So suppose you have a plus b squared, that would be a squared plus 2ab, the middle term is twice as much as what the product of a and b are, plus b squared at the end. So we have first term square, second term square, and the middle is twice as much as the product of those two. So when we have it in this form and we are going backward, we pay attention to that 8x right there. That would be that middle term, 2ab right there, right? So here's what I mean by completing the square. We're going to make that into the perfect square, looking like the vertex form. F of x is a lot of writing, so I'm going to go ahead and use y instead, just so that it's less messy. Here's the equation that we were given. If we think about the 8x being the middle term, and that is twice as much as the product, so when we go backward, we would be thinking the perfect square would have to start out with x, because x squared is your first term right here, right? So x is your first term in the perfect square, and then since this is the plus, this is going to be a plus right here, and so this is your a, right? And then this has to be 2ab. Well, your a is x right here, so 2ab would have to be 8, therefore b would have to be 4. Okay, so if b is 4, negative 2 is not a good number for us. So what we'll do is we'll go ahead and just add it to the other side and just leave it there, because it's not the right number for us to have a perfect square, right? What is the right number? If we square this perfect square up, we would get x squared plus, okay, 2 times 4 times x is 8x, plus the second term square, which is 16. So 16 is what we wish to have there. So we're going to go ahead and say, well, I wish I had 16 on the right hand side. Well, we know that this is an equation. So if we add 16 to the right hand side, it would be logical for us to add 16 to the other side so that the equation will stay balanced and we're not making any changes, right? We're going to change the way it looks, but not its value. So we're going to have to add 16 to both sides. And once I have 16, then the right hand side becomes a perfect square, and the left hand side will be left with y plus 18. Now, the last thing to do is just go ahead and undo the plus 18, subtract that to the other side, and we have a vertex form where this is going to tell us that we are moving left 4, and this is going to say down 18. Therefore, our vertex is at -4, -18. Okay, so that is how we complete the square. the process of going from the ax squared plus bx plus c into this perfect square form or vertex form is called completing the square, because we actually added a missing number 16 right here so that we can have a perfect square. That is why it's called completing the square. All right, now let's look at another example. Now that we've seen it once, let's see if we can think about this one here. Okay, so again, vertex form, perfect square. The middle term is twice as much. But wait a minute, how does that work when that's 3 and it's not nicely divisible by 2? Okay, that is perfectly fine. Okay, again, we would say if this was to be a perfect square, the first term is x because that's what I have here, right? And then the second term, and this is plus because that is plus. The second term is what in order for me to get a perfect square? Well, we see that a is supposed to be 2ab right here. Okay, a is x, so 2b would have to equal to 3. 2b would have to equal to 3. Therefore, b would have to be 3 over 2. So this number, the second term, is b over 2. Well, then the third term is supposed to be b over 2 squared. That's a perfect square, right? So 2 is not what we need. So we will go ahead and add 2 to the other side. We will go ahead and add 2 to the other side and deal with it later. And then we would say, I would like to get b squared. So b squared is going to be 3 over 2 squared. That's the missing term right there. So we're going to go ahead and add 3 over 2 quantity squared to both sides. And we know 3 over 2 squared is 9 over 4. Okay, now we add to both sides so that we do not change the equation. We do not want to upset that balance equation there. Okay, so add 9 over 4 to both sides. And when I have that added, I would have a perfect square on the right-hand side. And I would go ahead and combine the 9 over 4 and 2. 2 is the same as 8 over 4, so I would have 17 over 4 there on the left. And then one last thing to do is to go ahead and subtract 17 over 4 to the other side, and we get our vertex form. Okay, so then the vertex is -3/2, -17 over 4, because this plus 3/2 moving it to the left, and this minus 17 over 4 on the outside is moving it down. So we have vertex at -3/2, -17 over 4. Okay, so it's okay if the process is still the same, but if that number is not nicely divisible by 2, you may just get a fraction. It's a little bit harder to look at, but it's all right. We can do that. All right, now what's the difference between this problem and the previous 2? That has a leading coefficient. Okay, so process is the same. Go ahead and try to clean it up. Make sure you have that perfect square. Okay, so first thing first, I'm going to go ahead and write down the equation. I notice that I only need ax squared plus 2ab plus b squared to have a perfect square. So the 2 right there, I don't need the 2, right? And then the 4, we know that probably not going to be the right number anyway, so we'll go ahead and undo the 4 to the other side. it's sort of like my analogy here is cleaning your closet, right? So the right-hand side is your closet. Looks messy. Let's put it on your bed, meaning the left-hand side, and then deal with it later. Okay, what else do we not want in that closet? The 2. So go ahead and get rid of 2. How do we get rid of 2? Divide both sides by 2. Okay, divide both sides by 2 to get rid of the 2. Now it looks like the perfect square form that we needed. Okay, again, 2AB is 10, right? We know A is X, so 2B would have to be 2AB is 10X and A is X, so 2B would have to be 10, therefore B is 5. Now, you didn't have to write down all that. You can just think, well, you know, when you go forward, the 10 was twice as much, right? So half of 10 is 5, and then I have to square it, so half and then square that, that would be 25, so I'm going to have to go and add 25 to the left-hand side as well. Okay, so add that to the left-hand side as well to stay balanced. And now that I added the 25 to make a perfect square, my closet is nice and clean, has a perfect square on the right-hand side. So the next job is just to go ahead and put everything from your bed here back to your closet, starting with the plus 25. To undo 25, I'll go ahead and minus 25 to both sides, and that will be there. And then to undo divided by 2, I'm going to multiply everything by 2. Okay, and when I do that, I would have, oh, Vertex came too early. I would have y plus 4 is equal to, distribute the 2 in there. I would have 2x plus 5 squared minus 50, and then minus the 4 over. That is now in the vertex form. Okay, so this tells you that you are going to move to the left 5, down 54, and what is this 2 right here? That's vertically stretch the parabola. Okay, and so again, since we move left and down, your vertex is at -5, -54. Nice, right? Okay, now some of you might think, well, what if that coefficient is a fraction? How does that work? The same way. Okay, just pay attention to the process of undoing it. So, again, vertex form is a perfect square, so we know we have to go and complete the square so that we can tell where the vertex is and we can graph. So here we go. 1/2, we do not want the 1/2 there, so we would have to go ahead and multiply both sides by 2, right? Multiply by 2 to undo the 1/2 there. So multiply both sides by 2 because it's an equation. Whatever you do on one side, you got to do to the other side. And so that would be a common error if you were working on these problems. Make sure whatever you do the same to both sides. And the 1/2 is gone. I will have x squared plus 10x on the right, 2y on the left. Okay, half of 10 is 5, and then 5 square. Okay, it's half and square. Half, then square is 25. Okay. So the missing number is 25. We'll go ahead and add 25 to both sides. We have a perfect square. Okay. And then what we're going to do is to undo everything and move everything back. So minus 25 and then divided by 2. And when we divide by 2, we have 1/2. times x plus 5 squared minus 25 over 2. Okay, so the vertex is negative 5, negative 25 over 2. And that is how we complete the square. Okay, so remember, the biggest issue is whatever you do to one side, you do the same to the other. Do not forget to add to the other side. I know that's what the error is that I would make if when I am being careless and being so quick in doing these things. So make sure if you add to one side, you add to the other. Okay, that is it.